Hello everyone, welcome to my YouTube channel ClearPath QA. In this video session, today I am going to explain the new chapter Testing Throughout the Software Development Lifecycle. Actually, this is one of the easy chapters. From this chapter, there will be 6 questions. If you want to pass this exam, you can easily get full marks from this chapter. Sometimes you might be confused by chapter 1 questions, but this chapter is not like that. You can easily get full marks from the questions in this chapter. For that, firstly, you have to understand this chapter very well. So, now I am going to discuss about first concept testing in the context of a software development lifecycle. So, what exactly is a software development lifecycle, or SDLC for short? Think of it as a roadmap guiding us through the various stages of creating software. There are different types of SDLC models out there, each with its own approach. For instance, we have sequential models like the waterfall model and the V model, which follow a step-by-step progression. Then there are interactive models like the spiral model and prototyping, where development cycles repeat until the product is refined. Lastly, we have implemented models like the unified process, where the project is divided into smaller, manageable chunks. These models help us understand how different phases and activities in the development process fit together both logically and in terms of time. Let's zoom on some specific activities within software development processes. These are often described by more detailed methods and agile practices. Examples include acceptance test driven development, that means ATDD, and behavior driven development, BDD, domain driven design, DDD, extreme programming, XP, feature driven development, FDD, Kanban, Lean IT, Scrum, and test driven development, TDD. These practices and methods enhance the software development process, making it more efficient and effective. Let's delve deeper into the impact of the software development lifecycle on testing. Testing needs to be tailored to fit the SDLC for it to be successful. The choice of SDLC affects various aspects of testing: the scope and timing of test activities, including which test levels and types are involved, and the level of detail in test documentation, the selection of test techniques and approaches, the extent of test automation implemented, and even the roles and responsibilities of testers. Understanding how the SDLC influences testing is crucial for effective software development. In sequential development models, testers usually engage in requirement reviews, test analysis, and test design during the initial phases. However, since executable code is generated later, dynamic testing is often delayed until the later stages of the SDLC. In certain interactive and incremental development models, each interaction is expected to yield a functional prototype or product increment. This suggests that during each interaction, both static and dynamic testing can occur across all test levels, with frequent delivery of increments, fast feedback and thorough regression testing become essential. In agile software development, change is expected throughout the project lifecycle. Hence, agile projects favor lightweight. Additionally, in agile environments, manual testing often relies on experience-based test techniques which do not necessitate extensive prior test analysis and design. Let's discuss how the software development life cycle, that means SDLC, intersects with good testing practices. Every software development activity should have a corresponding test activity, ensuring that quality control is applied throughout the development process. Different test levels, it will be discussed in coming video, have specific objectives enabling comprehensive while minimizing redundancy. Test analysis and design for a specific test level commence during the corresponding development phase of the SDLC, ensuring adherence to the principle of early testing we discussed in a previous video. Uh, Testers engage in reviewing work products as soon as draft documentation becomes available. This facilitates early testing and defect detection, supporting the shift left strategy. Following these principles ensures true testing and maintains quality standards across the SDLC. PDD, ATDD, and BDD are similar approaches where tests guide development. They embrace early testing and a shift left approach with tests defined before code is written. They fit well with interactive development. Test driven development, that means TDD, guides coding through test cases rather than extensive software design. Involves followed by written code to fulfill those tests and then refining both test and code through refactoring. Acceptance test driven development ATDD derives derives test from acceptance criteria during the system design process. Involves written test before developing the corresponding part of the application to meet those tests. Behavior driven development BDD describes the desired application behavior using test cases written in a simple, stakeholder friendly form of natural language, typically using the given when then format. Automatically translates test cases into executable tests. In all of these approaches, test can be written as automated test to maintain code quality during future adaptations of refactoring. DevOps and testing. Testing in DevOps means bringing development, including testing, and operations together to achieve shared goals. This approach requires a cultural shift within organizations to ensure development, including testing, and operations work together effectively, valuing both equally. DevOps encourages team independence, quick feedback, using integrated tools, and technical practices like continuous integration (CI) and continuous delivery (CD). This allows teams to develop, test, and release top-notch code more swiftly using a DevOps delivery pipeline. From a testing standpoint, some advantages of DevOps include quick feedback on code quality and potential adverse effects on existing code. Continuous integration (CI) encourages a shift-left approach in testing. This will be discussed next by prompting developers to submit high-quality code along with components test and static analysis. Encourages automated processes like CI/CD, which help in setting up stable test environments. Broadens focus on non-functional quality aspects. Examples performance, reliability, like that. Sorry. Automation where delivery pipeline reduces the necessary repetitive manual testing, minimizes regression risks by employing a wide range of automated regression tests. Despite its benefits, DevOps presents certain risks and challenges, such as establishing and defining the DevOps delivery pipeline, in and maintaining CI and CD tools, allocating additional resources for test automation, which can be challenging to set up and sustain. While DevOps emphasizes automated testing, manual testing, particularly from the user's viewpoint, remains necessary. Shift left approach. The principle of early testing, see session 1.3, is often termed as shift left because it entails conducting testing earlier in the SDLC. Shift left typically advocates for testing to occur sooner, for example, without waiting for code implementation or component integration. However, it doesn't mean neglecting testing later in the SDLC. To achieve a shift left in testing, several best practices can be adopted, including reviewing specifications from a testing perspective. Such reviews often uncover potential defects like ambiguities, incompleteness, and inconsistencies. Written test cases before writing the code and running the code in a test harness during implementation. Utilizing continuous integration, that means CI, and ideally continuous delivery, that means CD, for swift feedback and automated component tests to accompany code submissions to the repository. Conducting a static analysis of source code before dynamic testing or as part of an automated process. initiating non-functional testing at the component test level whenever feasible. This represents a form of shift left, as these test types are typically conducted later in the SDLC when a complete system and representative test environment are available. While a shift left approach may require additional training, effort, and or cost upfront, it's anticipated to save efforts and cost later in the process. It's crucial for stakeholders to be convinced and fully committed to this concept. Retrospectives and process improvement. Retrospectives, also known as post project meetings or project retrospectives, are typically conducted at the conclusion of a project, iteration, or release milestone, or as necessary. The timing and structure of retrospectives vary based on the specific SDLC model being employed. In these meetings, the participants, not only the testers, but also example developers, architects, product owner, business analyst, like that, discuss what was successfully and should be retained, what was not successfully and could be improved, how to incorporate the improvements and retain the successes in the future. The results should be recorded and are normally part of the completion report. Retrospectives are crucial for the successful implementations of continuous improvement, and it is important that any recommended improvements are followed up. Typical benefits for testing include increased test effectiveness, efficiency. Example, by implementing suggestions for process improvement. Next, increased quality of test data. As example, by jointly reviewing the test processes. Another one, team bonding and learning. As example, as a result of the opportunity to raise issues and propose improvement points. Enhanced quality of the test basis. Example, addressing deficiencies in the extent and quality of requirements. Another one, improved collaboration between development and testing. As example, regular review and optimization of collaboration practices. Today's video is over. To catch up with more content, let's meet in the next video on my YouTube channel.